Alright, in this video we're going to start investigating trigonometric ratios of any angle. So, as a little reminder of how we got where we are now, suppose that you have an angle, adjacent leg A, opposite leg B, and hypotenuse C for the heck of it. We have access to a couple things. A squared plus B squared is equal to C squared, and we have access to our 6 trigonometric ratios that take the form SOHCAHTOA. So the sine of an angle is the opposite over the hypotenuse, cosine of an angle is the adjacent over the hypotenuse, and tangent of an angle is the opposite over the adjacent. So just a little reminder from a couple sections ago. If we were to draw a quadrant 1 angle and refer to it as theta, this would be an angle in standard position, this guy right here, we can create a reference triangle by connecting any point on the terminal side of this angle directly down to the x-axis. This creates a right triangle. You'll notice that the right triangle created right here and the right triangle that we started with are awfully similar to each other. Except, you know what? Instead of referring to this as C, I'm going to start referring to this as R. Now, from the rectangular coordinate standpoint, what we have here is essentially the ordered pair AB. So A is the x-coordinate, B is the y-coordinate. Now, what we're going to do is define our 6 trigonometric ratios the exact same way as what we did before. So opposite over hypotenuse, B over R. Cosine of theta would be adjacent over hypotenuse, A over R. The tangent of theta would be opposite over adjacent, B over A. The cotangent of theta would be adjacent over opposite, that's A over B. Secant, makes me laugh, ha, hypotenuse over adjacent. And cosecant, well, cosecant's a hoe. That's the hypotenuse over the opposite. You'll notice that at no point in here did I say that it is mandated that theta has to be a quadrant 1 angle. So we'll pose the question, what if theta is not in quadrant 1? Well, the first place we could go with something like that is quadrant 2. So let's go ahead and extend this into quadrant 2. So this time, once again, we have an ordered pair associated with this. We can label sides as A, B, and R once again. Now technically, this would be our angle right here. That would be the angle known as theta. You'll notice that I'm still creating a right triangle, but this angle theta is no longer inside of the triangle. And for that, we're going to introduce something new. And the new thing that we're going to introduce in quadrant 2, I'm going to refer to this angle as beta. Beta is going to be this guy right here. Beta is known as a reference angle. So this is the acute angle that's created in a reference triangle between the terminal side of the angle and the x-axis. So this is the acute angle in the reference triangle made with the x-axis. So just to give you an idea of what reference angles look like in all of the different quadrants, that would be for quadrant 2. In quadrant 3, reference triangle would be created in the following fashion. We'll refer to this as the angle theta. Create a reference triangle by connecting the terminal side down here. The angle gamma in question would be this angle right here. So that's how we get a reference angle in quadrant 3. In quadrant 4, if I were to draw an angle in standard position, and say that this is referring to the angle theta, the way that we create a reference angle for this one, we'll go with the 4th Greek letter for this one, that is delta. So this acute angle, and this acute angle are all referring to reference angles. Now the way that we calculate the reference angle changes a little bit from quadrant to quadrant. So let's talk about how to do that. Now these acute angles are all going to be measured the same way, and that is by taking the measure of the terminal side of the angle and subtracting the measure of the initial side. Now by that I mean the two sides that are creating this angle are known by an angle measurement of theta and whatever this angle is right here. In standard position, this would be either 180 degrees or pi radians. To create an acute angle going from here to here, we're treating theta as the initial side and the negative x-axis as the terminal side. So the way that we would calculate beta is by taking the terminal side, 180 degrees, and subtracting the initial side. Or if we wanted to measure this in radians, that would be pi minus theta. In quadrant 3, once again, we're referring to this side as one of the sides creating the angle, and that's 180 degrees or pi radians. However, to create the angle gamma, this time we're treating 180 degrees or pi radians as the initial side and theta as the terminal side. So the way that we would calculate gamma is by taking the terminal side and subtracting the initial side, or theta minus pi. And finally, as a quadrant 4 angle, you'll notice that these two angles together would add up to 2 pi or 360 degrees. So this angle we would be treating as either 360 degrees or 2 pi in terms of radians. So we're treating theta as the initial side and 360 degrees or 2 pi as the terminal side in order to guarantee that delta is a positive value. So the way that we would calculate delta is we take the terminal side, 360 degrees, minus the initial side, which would be theta, or 2 pi minus theta. Now, once you have your reference angle, we can construct the reference triangle using all of the appropriate sides. It's just a matter of labeling things as being either positive or negative, depending on the quadrant of origin. So with that in mind, let's try out a couple problems together. First thing I'd like to do is find the cosine of 120 degrees. Cosine of 120 degrees. Generally speaking, what I'm going to encourage you to do is first sketch the angle in question. We've been given degree measures, so I'm going to label all of my quadrantal angles in terms of degrees. So first big important thing is to determine 120 degrees would be contained within which quadrant. Well, 120 degrees is between 90 degrees and 180 degrees. In fact, it's 30 degrees more than 90 degrees. So 120 degrees would be approximately right here. To construct our reference triangle, we connect the terminal side down to the x-axis. And we can now construct our reference angle, which is this right here. So this angle is referring to a 120 degree angle. I'm interested in calculating the reference angle in here. So for the reference angle, this would be the angle created between 180 degrees and 120 degrees. Take the larger angle minus the smaller angle, and we get a reference angle of 60 degrees. Now, given that the reference angle is 60 degrees, we should be able to calculate the other angle up here as being 30 degrees. You are looking at the old 30, 60, 90 right triangle. Now, according to our important triangles, across from the 30 degree angle should be 1, across from the 60 degree angle should be the square root of 3, and the hypotenuse should be 2. However, we're in quadrant 2, and in quadrant 2, anything that is over on the left-hand side should be considered a negative value. So with that in mind, if I'm interested in calculating the cosine of 120 degrees, then I am going to need the adjacent side from our reference triangle over the hypotenuse. The adjacent side is -1, the hypotenuse is +2. Final answer for this one is going to be -1/2. let's take a look at another example, just because it'll be beneficial to do so. I would like to find the sine of 5 pi over 4. This time we'll be working in radians. So for 5 pi over 4, first thing I want to do is label my quadrantal angles. We'll go 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now when working in radians, sometimes it can be a little bit more difficult to figure out where things are, so I want to express everything in here in terms of our common denominator of 4. Pi over 2 is the same as saying 2 pi over 4. Pi is the same as 4 pi over 4. 3 pi over 2 is the same as 6 pi over 4. 2 pi is the same as 8 pi over 4. Once you have that common denominator in place, determining where 5 pi over 4 becomes a little bit easier. 5 pi over 4 is exactly halfway between 4 pi over 4 and 6 pi over 4. So my reference triangle will look like this in quadrant 3. Now as far as my reference angle is concerned, that would be this little guy right here. In order to calculate that angle, I'm going to take the larger of these two angles and subtract the smaller of these two angles. The two angles in question being 5 pi over 4 and 4 pi over 4 to construct this angle. So for the reference angle, this is going to be 5 pi over 4 minus 4 pi over 4. And it's a good thing we got that common denominator. That'd be pi over 4, or for those playing along in terms of degrees, this would be a 45-degree angle. Now, 45-degree angle means that we're working with the old 45-45-90 right triangle. The two legs should be labeled as 1 and 1, and the hypotenuse should be labeled as the square root of 2. Given, however, that we are in quadrant 3, I would want to make sure that the x-coordinate is negative and the y-coordinate is negative. Once you have that set up, we're looking for the sine of this angle. Sine would be the opposite over the hypotenuse. So the opposite over the hypotenuse would be -1 divided by the square root of 2. So you could call that -1 over the square root of 2 or negative root 2 over 2. And finally, one more example. I would like to find the tangent of 330 degrees. For the tangent of 330 degrees, once again, we're working in degrees. So we'll label all of our quadrantal angles, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and finally 360 degrees. 330 degrees would be contained between 270 degrees and 360 degrees. That would be in quadrant 4. I'm drawing it so that it's a little closer to 360 than it is to 270 because that is how numbers work. Drawing our reference triangle. We are now interested in calculating this angle right here. Now, to calculate that angle, we need the angle between 360 degrees and 330 degrees. So for that reference angle, I'm going to take the larger angle minus the smaller angle. Wait, how do you draw an R? There we go. The reference angle is going to be equal to the larger angle, 360 degrees, minus 330 degrees. That reference angle is a 30-degree angle. Now, given that that is a 30-degree angle, like the top example, that means that we are dealing with the 30-60-90 right triangle. For the 30-60-90 right triangle, across from the 30-degree angle should be 1. The other leg should be square root of 3, and the hypotenuse should be 2. Given that we're in quadrant 4, though, we want the x-coordinate to be positive and the y-coordinate to be negative. So within this triangle, we are going to be looking for TOA of SOHCAHTOA. That is the opposite over the adjacent. So opposite would be -1. Adjacent would be square root of 3. And if you feel like rationalizing this denominator, well, that's fine. I've been able to rationalize lots of things in the last couple days, like eating an entire hot and ready for meals for a day. Wow, that was too much information. All right, hope you guys enjoyed, and we'll do more examples in the next video.